All right, everybody. I've been recording videos all day, and this is my finish line right here. This monster. So loosen up, get your stretch on, and once this is done, then I don't have to record any more videos today, and I'm real excited about that. I'm going to apply a lot of the ideas of what we've been dealing with in chapter 4 in order to find all the roots, real and imaginary, of p of x here. So this is a big polynomial. It's got a lot of things going on with it. So the first thing I want to do is I want to try to get some of the easy real zeros out of it. So it wants me to find the roots, but I can't identify the roots really easily off of this. But what I can identify from the graph is x-intercepts. And x-intercepts are the same as roots. So let's take a look at this graph. Where did my graph go? Here it is. So checking out my graph, I typed it into Desmos because it's just a little easier for me to manipulate. I've got zeros here at 1, 2, and 3. So I know that there have got to be 5 zeros to this polynomial because it's degree 5. According to the fundamental theorem of algebra, since it's degree 5, I should get 5 zeros for this thing. I am noticing that I've got 3 here, and they all seem to shoot straight through. Now, they might have some sort of cubic thing going on there, so there might be more zeros. There might be a higher multiplicity there, but it seems like those are all linear zeros. I won't know for sure until a little bit later, but this function is just too big and changing too rapidly for me to really easily identify if that's linear or not. They seem linear, though. So it seems like those are just going to be multiplicity 1. So there seems to be 2 other zeros that I don't know yet. I'm looking this way and I'm not seeing anything, and I'm looking this way, I'm not really seeing anything real soon. So there could be ones, but I'm starting to suspect there might be some imaginaries. This thing kind of does a little loop-de-doo there, but it's not very much. Again, it's just changing too rapidly at this point to really identify if there are any imaginary zeros. But I definitely know 1, 2, and 3 are some great x-intercepts. So those are going to be the first things I'm going to divide out of my polynomial. So let's start with that. So, excuse me. Cool. Please don't crash. So I know I've got some zeros at 1, 2, and 3. So I'm going to start by trying to divide those out. And I'm going to use synthetic division. The problem's beefy enough. So I'm just going to use synthetic division because that makes my life easy. So grab my leading coefficients, 20, negative 60, 99, and negative 54. And I'm going to use 1 first because that's really easy. So this is the one that I'm going to have to do the most work with. So I'm going to use 1 because that'll just make my life really easy. So I drop the 1, I get 1. I put the 1 here because I do 1 times 1. I can do that even as tired as I am right now. All right, 20 times plus, not times, I get 15. That's a 1. 15 times 1 is still 15. Add those together, that is negative 50, negative 45. Let's see, negative 45. Add those together, that should be positive 54. And then this is 54. Add those together and we get 0. Cool. That's my first one. So I know at this point that p of x equals 1 x minus 1. So that's my first 0 that I factored out or divided out. And so this is x to the now the 4 minus 5x cubed plus 15x squared minus 45x plus 54. Cool. And I got a key of when I've done this before, and that seems to be matching up in my quick check. Cool. Tired run check brain do not like to do thing unknown. So I've got another 0 at 2, so I'm going to use that one next. And I'm going to grab my leading coefficients again. And I'm not even going to copy them out of my polynomial. I'm going to copy them off of, like, I'm just looking right there for them. I'm not copying them out of the polynomial. I like writing that so I can kind of have like a little checkpoint of where I'm at, but I'm not going to use those. All right. Cool. Let's synthetically divide again. So drop this. So that's 1. Now I got to actually multiply in this step instead of copy. 2 times 1, that's 2. Add these together, that's -3. 2 times -3 is -6. Add these together, that's 9. 2 times 9, that's 18. Add these together, that's -27, I think. Yeah, cool. And then 2 times -27 is -54. And now I'm definitely confident because I got 0. I know that it is a 0, it is a factor, so it should come out nicely. So now how is P of x looking? We still have our x minus 1, but now we have our new one of x minus 2, and our degree dropped down by 1. So now we have x cubed minus 3x squared plus 9x minus 27. All right, now I know I've got one more 0 of 3, but I'm going to take another look at my graph. Now that I have something that's a little bit more manageable and it's going to behave itself a little bit better, let's take a look at what that thing looks like. So now we have x cubed minus 3x squared plus 9x minus 27. I'm just kind of copying this off my key. Nope. And I want to kind of compare it to that. Cool. Nope, don't need that. Okay. All right, so yeah, look at that. Look at this thing freak out a little bit. See how it kind of has this weird kink in it? I don't really like that weird kink. That weird kink, I think, is an imaginary 0. I'm starting to feel more and more confident about that imaginary. We should still have a 0 of 3 right here. Yep, still got that 0 of 3. But yeah, that kink doesn't look right. That doesn't look quite right. That's probably an imaginary freaking the thing out. So let's get that 3 out and see what sort of imaginary garbage we're left with. I know what imaginary garbage we're left with because I have the answer over there. Shh. All right. Oh, I'm so tired. All right. Leading coefficients. Oh my gosh, it's so much less beefy now. Drop this 1. So that's 1. I almost wrote 3. 3 times 1 is 3. Add these together, we get 0. 3 times 0, that's going to be 0. And those together we get 9, and 3 times 9 we get 27, and we get 0 again. Good, good. Okay. So now P of x equals the first factor that we took out, x minus 1, our second factor that we took out, x minus 2, and now our third factor that we took out, x minus 3, and our remaining chunk. Before we had a cubic, and so now it is squared. We have no x term, but we do have a constant of 9. Well, now you can really tell that we've got something that is not touching the x-axis. If we go back to Desmos and we graph that one more time, if we took a look at this graph, we can see, look at that thing. We know that's a quadratic shape. It's a nice U shape, but it's never going to touch the x-axis. Since it's never going to touch the x-axis, it has no real zeros. It only has imaginary zeros. All right. Well, let's find them. We can find them using good old solving by square root, because zeros and solutions and x-intercepts are all the same thing. So let's find the solutions that would make this thing into 0. Find the solution to this equation. So we get x squared equals -9. Then we square root both sides. And so we get this, we get plus or minus, excuse me, I'm not that tired that I'm going to forget a plus or minus. So we get plus or minus, the square root of 9 gets us 3i. So those are our imaginary roots that were kind of messing with the thing the whole time. So the question was looking for all the roots, real and imaginary. So our roots were 1, 2, 3. Those were our real ones. And then we have 2 imaginary. Plus or minus 3i, which is good. We should always get pairs of imaginary roots. And according to the fundamental theorem of algebra, that degree 5 polynomial was supposed to have 5 roots. And guess how many we got? 5. Yeah, I am done. I don't have to record any more videos today. Yes. You have a good day. Thank you for watching.